Kia ora everyone. I'm here to go through the 2020 Derived Grade Examination for Tauranga Girls College Level 1 Demonstrate Understanding of Aspects of Acids and Bases. If you don't go to Tauranga Girls College, you're more than welcome to read this. Our exam is quite different to other schools as we have made it ourselves, so don't think you can use it to help you pass your own school's exam. So this is a 4-credit exam. It should take you about an hour. And you should also have with you the resource sheet, which I actually don't have physically, but I've just got here up on my laptop. So let's open the booklet and let's start working. So our first question is about atoms, ions and formulae, and it's got a nice table that we need to start with. So looking for fluorine, if we look that up on the periodic table, we can see that it is atomic number 9, and we can also see up the top here it is in group 17 and it is in period 2. Okay, so its atomic number is 9. This gives us its number of protons, and the electron arrangement is 2 in the first shell, 7 in the second. Remembering 2, 8, 8, 2 is something we need to remember for ourselves. The electron arrangement of the ion here, we need to get a full outer shell to make an ion, so that is going to gain 1 electron. It has now got 9 positive protons and now 10 negative electrons. With 1 extra negative, it is going to be F1 minus. Looking for sulfur here, we can see that sulfur is atomic number 16. So atomic number 16, so it's got 16 positive protons. 2, 8, 6 adds up to 16. To make an ion, it needs to gain 2, so it will be 2, 8, 8. And now it's got 18 negatives and still 16 positives, so therefore it's S2 negative. And the last one is calcium. So if we look over here, calcium is number 20. So 20 positive protons, arranged electrons are 2, 8, 8, 2. And it needs to lose these 2 to get its full outer shell, which will take it to 2, 8, 8. It now has 20 positive protons and only 18 negative electrons, so it is Ca2+. We had to get any 2 of these rows correct essentially to get a little a here. Looking carefully at this question, we have to look at explaining why the ions formed by sulfur and calcium have the same electron arrangement and yet have different charges. So let's look up here. Sulfur and calcium ions have the same electron arrangement and different charges. If you didn't have the same electron arrangement and different charges at this point, this would alert you to the fact that you have made an error up in the table. So make sure that everything is consistent. So we need to basically answer this question, and in our answer we have to meet all of these bullet points. So we need to describe the difference between an atom and an ion, explain the charges of sulfur and calcium ions in terms of number of protons and electron arrangement. Let's have a look up here. Here is our number of protons and here are our electron arrangements. So for this bullet point here, all we are doing is putting this information into words. We then have to relate the position of sulfur and calcium on the periodic table to the charges on the ions. Let's just make some notes about this first. So we know that atoms are generally unstable, with a few exceptions, and they are neutral. So atoms have the same number of protons and electrons. Ions, however, are stable. They now have a full outer shell, but they are electrically charged. They have a positive or a negative charge on them. Right, the charge on the sulfur is S2 minus and calcium ion, and we have to work out the number of protons and electron arrangement. We did this when I did the table, so we just need to put this into words. This one's a bit different. The position on the periodic table to the charges. There's lots of different things about the position, but the one that relates to the charge is the group. So for example, sulfur, let's just nip over here, is in group 16, which means it has 6 valence electrons. All of these have 6 and they all need to gain 2, so they all form a 2 negative, O2 minus, S2 minus, so on and so forth. Okay, so over here we'd be thinking sulfur group 16, therefore 6 valence electrons, therefore gains 2, therefore 2 minus charge. And for calcium, we would be saying group 2, therefore 2 valence electrons, therefore loses 2, therefore a 2 plus charge. So what I've done here is I've just jotted down a few notes to make sure that my answer is right. I'm not actually going to go through the answer now because all I need to do is write sentences about these. Common mistakes that people had were not actually telling me how many protons and what the electron arrangements were. So let me just write an example for that. So I would say that the charge on the calcium ion is 2 plus. And I wanted to explain why that was. So calcium is atomic number 20, therefore it has 20 positive, and I'd write that word if it was me, protons. Its electron arrangement is 2882. Therefore, it needs to lose 2 electrons to get a full outer shell and become stable. And it now goes to an electron arrangement of 288. It now has 18 negative electrons. So with 20 positive protons and 18 negative electrons, it has an excess of 2 positive charges, which gives it a charge of 2 plus. You can go and look up the mark schedule to have a look at the answer better, but I think this gives you the ideas that you need to carry on with. Don't forget, you need to be specific. So you need to start with calcium is, sulfur is. Don't start with, we can figure out the number of electrons by this and don't also say things like the group of an atom gives us the number of valence electrons. Say calcium is in group 2, which means it has 2 valence electrons. So just get straight into the specifics. That's a really, really key point. Lots of you have been writing very, very waffly general opening statements. You do not need to do this. It's just a waste of time. Okay, let's go on to the next part of the question. So this is about the ratio of ions in an ionic compound. And this is calcium reacting with fluorine to form calcium fluoride. So we need to say how is the ratio related to the charge on the ion and give the number of electrons gained and lost and how that relates to the ratio in the ion. So the ratio to start with, given in this question here, is 1 calcium to 2 fluorines. We should call it fluoride if we're talking about the ion. Right, so the first part is how is the ratio related to the charge on the ion? And CaF2 is a neutral compound. And I want to see that written somewhere in your answer, is a neutral compound. So therefore, this means that the number of positive charges must be equal the number of negative charges. So as Ca has 2 positive charges, we must have 2 fluoride ions to give us 2 negative charges to make our neutral compound. Okay, that's the first part. The second part is to do with the electrons gained and lost, and it's really all related. To get the charge of 2 plus, calcium had to lose 2 electrons. These electrons had to be transferred, in this case, to fluorine. However, each fluorine needed to gain 1 electron only. So let's remember that fluorine, and remember we did do this over here. Fluorine 2,7 needed to gain 1 to make 2,8. Okay, so we can just transfer that into our answer. Therefore, we need 2 fluorines to gain the 2 electrons, 1 per fluorine, that 1 calcium lost. And therefore, the number of electrons lost would equal the number of electrons gained. So there's some really key phrases in there. Neutral compound is a key phrase, and number of electrons lost equaling number of electrons gained. Try not to meld them all together. Really make it clear that you understand the charges cancel each other out to make a neutral compound, and the number of electrons lost must equal the number of electrons gained. Try not to use the word balanced in here because it's a little bit tricky and we don't really know what that means in that situation. Right, so that's the end of question 1, and you're likely to get a question that has something about why ions form and something about ionic compounds. This question did not ask what an ionic bond was, and that is something you should go and look up if you don't know it. Right, that's the end of this one. I'm going to do this question by question, so I'll catch you for the second question in a mo.